your web pages are parsed into a DOM in memory. And we can prove that by coming up here and going to Web Developer, is it Inspector? And you see how the inspector shows me this. This looks like HTML that you're looking at here, right? But it's actually a DOM. I know that because every time I hover over something, it actually highlights the part I'm hovering over. And you can open stuff up and you can see exactly which part of the DOM you're referring to. So inside your web browser is a big tree of objects. How did that tree of objects get there? Your browser parsed the HTML into a DOM. You can use JavaScript to muck with the DOM. So you could come along and write some code that says, hey, take this object and change the contents of its text. And what will happen is way up here on your web page, that text will just change because Firefox renders its HTML DOM. Does that make sense? Yeah. Sorry, I keep saying Firefox. That's just because it's the browser I'm used to. All modern web browsers do it this way. Yeah, there are some old web browsers that didn't, but you would really have to dig to find one. So yeah, all browsers have a DOM. You can use JavaScript to mess with the DOM. You can change what's in the DOM. You can add to the DOM, remove to the DOM. And what the user will see is the web page is changing on the fly. And it doesn't actually have to load a new page. You don't have to refresh it. It just, JavaScript starts changing what's on the page. Have you ever seen a website that changes? Okay, that's called active JavaScript. And if it also is talking to a server, then it's AJAX. Although it's really AJAJ because we're using JSON. Okay. JSON is also a document object model. In the case of JSON, though, we're going to be sending whatever we want, converting whatever we want into JSON, which can be written as a string and sent through a pipe to the other language, which can then parse that string into JSON again. Do you see how JSON is useful for facilitating communication between computer programs? Okay, if I were to ask the question, why is JSON a good way to communicate between computer programs? The answer is what? Nobody knows what to say. Here's the deal. When you write a computer program, you have objects all over the place, right? You could convert those into JSON really easily because JSON is kind of designed to mirror objects. You have objects in JSON which have fields, and you have lists which are basically arrays, and you can turn any objects into JSON. Do you believe that? Do you remember doing that? Are you convinced? Okay. And you can convert JSON back into objects. So imagine you have a computer program, which I'll represent with a color green here, running on this client, and it's got a bunch of objects in its memory. You can convert those to JSON, which can be converted to a string, which could then be sent up the wire and through the cloud and down to Houston and back up to your internet provider and up to the server. And then the server could take that string and could parse it into a bunch of objects. And now basically, imagine if you had telepathy and you could communicate with some other person by just sending them your thoughts. Wouldn't that be awesome? That's kind of what computer programs do, because to a computer program, its thoughts are this memory that's full of objects. And you can actually take objects, however many you want, package them up into a string, send the string over the internet to the other program, and it unpacks it into a bunch of objects. And if you think of that all as just one instantaneous step, it's not exactly instantaneous, but there's libraries and packages that do this, then essentially it's as if the program can just send whatever it wants, just take from its brain. You could take the whole model and ship it off to the other program. So you know how we had AI that was forking models into copies of models because we made deep copies? Well, you could even send your deep copies of your model way up over here. And so now all of a sudden, the whole internet is working together in one big, massive intellectual attempt to think and process the universe. And that's kind of what's happening these days with the internet. You follow? Kind of? Okay. how does one convert a bunch of objects? Well, let's start with this. Let's suppose you're in JavaScript. How do you take a JSON string and convert it to objects? In JavaScript, suppose you have something that looks like this. Field value, I guess this would be name. This is a JSON string for an object that has one field named name with a value of value. Okay? How would I convert this string into objects in JSON in JavaScript? I would say let ob equal that, and bam, it just works, because JavaScript is really designed to integrate with JSON. There's also JSON, JavaScript, JSON.parse. Oops. Wow, I said JSON and my fingers just wrote the name Jason. That's okay. There's something called JSON.parse. What does this do? Suppose you have a string and you say var object equals JSON.parse, and then you put the string inside of here. What do you suppose that does? Here's what I'm saying, is instead of saying that, I can say let ob equal JSON.parse like this. And I'm assuming there's a tick mark here to delineate that as a string and a close parenthesis, and we'll put a semicolon too. Okay. How do these two lines differ? The answer is they don't. They do exactly the same thing. So what's the point of JSON.parse? Well, you might very well have a string that, the difference is that it's a string. See, okay, I didn't explain that very well. Let me try again. See how I put tick marks around that thing? In this case, ob points to an array in memory that actually holds these characters. Ob is now a string. If I don't have those tick marks, ob is now a tree of objects. So if you have a string, and this is kind of weird because there are no types in JavaScript, but you have to remember what type it is because memory is still in types. If you have something enclosed in quotation marks, let stir equal quote name value. At this moment, stir is actually a string, right? Now if I said let ob equal stir, is that going to parse the JSON string? No, because it's just going to copy the string, and so now ob is going to be a string too, and they're still going to refer to the same string. However, if I say let ob equal JSON.parse stir, now the string is actually parsed into a DOM, and that DOM is attached to ob. Am I baffling you, or is that just boringly clear? Nobody wants to give me feedback, so I will guess it's boringly clear and move on. It's okay to ask questions, by the way. Yeah, JavaScript is weird that there are no types, and you're all used to types because we've been programming in Java this whole semester. Essentially, think of variables as just an arrow or a pointer. They point to something, and what they point to, you just got to manipulate that thing they point to. So in JavaScript, not putting quotes around JSON actually means the DOM, the tree of objects. And putting quotes around it means, oh, it's actually a string. And when you say an equal sign, that just points the variable to refer to whatever you're pointing to. So you have to call JSON.parse to parse the string into a JSON DOM. Okay. Let's see, JavaScript to JSON. How do we do that? Stringify. If you say json.stringify j, where j is some bunch of objects, whatever objects they may be, JSON will, or JavaScript will convert that whole thing into a JSON DOM. So now you know how to go to and from in JavaScript. So in Java, not JavaScript, a char has 8 bits. No, that's not true. A byte has 8 bits. A char, I think it actually has 32 bits because they use Unicode, because Java was written back before people figured out UTF-8 was better, and chars actually waste a lot of memory. An int has 32 bits because it was written before 64-bit machines were popular. And a double has 64 bits, and that's how much memory it takes up. In JavaScript, so this is all Java. In JavaScript, sorry for answering slowly, there are no types. But if you put something in, how can I express it? Here's the point. Every implementation of JavaScript is at liberty to do it differently. So the programmer has no guarantees as to what an integer looks like in memory. It's just up to the computer to do a good job of it. And I think that's mostly true. There might be a specification somewhere, but it's a very vague specification if there is. Essentially, you don't know how much memory it's going to take. You just know that it's going to behave like an integer if you start using mathematical operations. If you use a plus between strings, that concatenates. And if you use it between integers, then it adds. And if you do something like this, it's going to do something smart, like convert this one to a string and then concatenate them. And I don't know what happens if you do this. Maybe it interprets that as a number. I'd have to do some testing to even figure it out. So you kind of have to think a little differently with JavaScript, and to a large extent, it's asking you to trust it. So you just have to trust it's going to take care of memory okay, and you're not supposed to worry about it. Is that a fair enough answer? Okay, yeah. Yeah, well, I guess the best answer I can give is because it's complicated. They are going to do everything in hash tables or whatever object structure they think is appropriate, and so we're just kind of asked to trust JavaScript, and it ends up doing all kinds of optimizations to try and make it efficient, and there's historical reasons, and it was never meant to be a serious programming language anyway. It's now just been hacked to pieces to make it into a real programming language.